We're going to take a look at a couple of problems from Chapter 11. Initially, we're just looking at ANOVA, one-way analysis of variance. In Chapter 11, on one of our homework problems, here we have a data set that's already been analyzed, and we're looking at the ANOVA results. Now, this particular problem says to use a 0.05 significance level to test the claim that the mean weight loss is the same for these different diets. There's 6 different diets in this data set. The degrees of freedom between groups, therefore, is 5. Our p-value from this study is 0.029581. So just like when we were doing hypothesis testing, if it's less than the significance level, we will reject HO. Now recall in an ANOVA problem that your HO, your null hypothesis, is that the means for all of your populations are the same. So in this particular case, the null hypothesis is that mu1 equals mu2 equals mu3 equals mu4 equals mu5 equals mu6, or that the mean weight loss is the same for all 6 diets. We are rejecting that because our p-value is small, indicating that there's a significant difference in some place. Now, that is for the type of problem where we already have a printout like we did here. If you click through and you take a look at your homework, this particular problem has raw data instead. The question is regarding car crash experiments. The data values are in the table for the chest deceleration data for the dummy and the driver's seat in different sizes of cars, sorted by compact, mid-size, and full size. So we're going to use the 0.05 significance level to test the null hypothesis if the different categories have the same meaning. We're going to go ahead and open that up in StatCrunch. And we are now going to take a look at ANOVA one way. We're going to hold down your control key or your shift key, and click all 4 columns. And everything else is pre-built in, so go ahead and click compute. Move this up and take a look here. Here's the mean and standard deviation for each of those columns. Down here's our ANOVA table, our calculated F statistic, and our p-value, which in this case is 0.0021. If we take a look at the problem again, the significance level, the alpha, is 0.05, this is 0.0021. It is less than significance level, which means we would reject HO and assume HA, meaning that there is some difference between the deceleration chest data for those 4 cars. We don't know exactly where it is. We might have a suspicion, but we have proven that there is a difference between those 4 types of cars. And again, you can go through here. You'll see some other questions kind of built along the same lines, some with data, some with results, some just asking you to think about concepts. Now we're going to return momentarily here to StatCrunch, and we're going to take a look at another type of data that might occur, another type of ANOVA. And so I'm going to load a shared data set. Okay, so in this particular data set problem, we're looking at hamburgers, and we are curious, is there a difference between the restaurants and the total amount of fat that is in the hamburgers? So I could do one of 2 things. I could sit here, take the data for McDonald's, Burger King, Wendy's, and make separate columns for pulling these out manually, or I could let the computer do it for me. So I'm going to click ANOVA one way. Instead of using selected columns like this, I'm going to say, take the values from a single column. In other words, take the total fat and sort it by fast food restaurant. So what I'm telling the computer to do is to take my data and to reorganize it for me. So I can see my restaurants, their mean, their standard deviation, standard error. Down at the bottom, I see my ANOVA table, my calculated F statistic, and my p-value. Now my p-value here is pretty small, 0.0001. So if I had a typical alpha level 0.05, I would end up rejecting HO, assuming HA, indicating that there is a difference between a fast food restaurant and the amount of fat that is in the hamburgers. Hope that helps.